welcome to my YouTube channel. In today's video, we'll be considering proximate composition. And so what is proximate composition? Proximate composition is the relative amount of moisture, protein, carbohydrate, fat, fiber present in a food sample. And so in today's video, we'll be considering moisture content determination by oven drying. Now, why is moisture content determination? Moisture content is very important in proximate composition. Now, moisture content is of importance because a food sample that contains a high moisture content is likely to have a reduced shelf life because the probability of microorganisms dwelling in that food is very high, and so there's a probability that the food will deteriorate with time. But likewise, a food whereby the moisture content of that food is very reduced, there is a certainty or a probability that the food sample will last longer because microorganisms are likely not to dwell, or their dwelling is very reduced in such a food sample. And so today we are going to be considering moisture content determination by oven drying, whereby this analysis was carried out in the university, in Rivers State University. And so in this table we have our sample, which is a food sample, but in this case we have white Gari and then we have yellow Gari. Now in this case we are trying to determine which of these food sample has a higher or a lower moisture content with respect to each other. And so we have the sample, we have white Gari, we have yellow Gari. And so the principle behind this moisture content determination by oven drying is by removing the moisture present in the food by heating the food at a particular temperature for a particular time. So with this table, we have that first thing you do in this analysis is, the first thing is you get your can, which to be used to carrying the food sample. Like in this case, we have white Gari and yellow Gari. So now the first thing you do is you get your can. When you get your can, now the first thing is you make sure you wash the can properly, and then you put it in the oven, and then you dry it at the temperature of 105 degrees for 15 minutes. You dry it, and then when you dry it, you put it in a desiccator. Now the desiccator contains calcium chloride or a granular silica gel. Contains calcium, also contains granular silica gel. And so these two guys are called desiccants. And so in the desiccator we have the calcium chloride and the granular silica gel. Now the work of these two substances, or these two chemicals in the desiccator, is to help to remove moisture in the can or in any apparatus or in any food sample that is being put in the desiccator to cool. And so the purpose of putting it in the desiccator is to allow either the apparatus or the sample to cool, then before we now use it for the purpose for which we want to use it for. And so when you heat the can in the oven, what you now do is you remove it using the metal tongue. You use the metal tongue and then you remove it from the oven. Then you now put it immediately inside the desiccator. Now the desiccator we said contains this granular silica gel and the calcium chloride. Now these two desiccants help to remove moisture from any of the substance or the apparatus that is being put in the desiccator, thereby helping it to work to cool. And so now we have the desiccator, and so now when they put it in the desiccator, now what they now do next is you take the moisture, the can from the the desiccator and then place it in the weighing balance. When you place it in the weighing balance, in that way you are trying to know the weight of the can. Now when you get the weight of the can, now you put your sample inside the can. Now when you put your sample inside the can, what you now do is you measure the weight of the can plus the sample that was put inside the can. And so when you measure their weight, now you now take it to the oven and then you now dry it at the temperature of 105 for 1 hour. Now when you put it in the oven, now you dry it in the oven at the temperature of 105 for 1 hour. Now in that way, you are indirectly or directly removing the moisture in that food sample. Now you're removing the moisture in that sample by heating it at that temperature. Now when you heat it at that particular time, you remove it immediately. You put it in a desiccator and then you allow it to cool. Now when you allow it to cool for 15 minutes, allow it to cool for 15 minutes. Now when you allow it to cool for 15 minutes, remove it and then you now go to the weighing balance. Now you weigh it again. Now when you weigh it again, you find out that at the end of the day, the weight of the can plus the sample that you put inside will be reduced with respect to the weight of the can plus the weight of the sample before it was dried. And so the principle is by removing the moisture from the food sample through oven drying or air drying. And so that is exactly what was done in this analysis. And so we have the sample, and so this is the weight of the sample. Sorry, this is the weight of the can, 25.32 gram. And so this is the weight of the sample. These two samples were weighed. Now their weight was 2 grams. For white Gari it was 2 grams, and for yellow Gari too it was 2 grams. And so when you weigh them, now you now put it in the empty can. And so you now have this sample weight plus the weight of the can before dry. And so when you add it for yellow Gari, the weight of the can was 25.235. And so when you add it to 2 grams of the white Gari, you now have 27.235 grams. Now for yellow Gari, you have the weight of the can to be 24.592 grams. And so when you add it with the sample weight of 2 grams, we had what? 26.592. Right. So now the next thing was, after it was now put in the oven and dried, now the weight of the can plus the weight of the sample weight plus the weight of the can after dry, for white Gari we now have 26.947 gram. Now for yellow Gari, after it was dried, we had 26.359. Now compare these two figures, the weight of the can plus the weight of the sample before dry. For white Gari had 27.235. This is the result after drying, 26.974. Now we had 26.592 for yellow Gari, and after dry we had what? 26.359. And so in this question, now we are being left with the space of the moisture loss and the percentage moisture loss. And so how do we get the moisture that was lost? As simple as that. First, for white Gari, now for white Gari, the amount of moisture that was lost in the food sample is the weight of the can, or for white Gari, we say that the moisture loss is equal to, now the weight, we say the weight of, or say weight of sample plus weight of can before, let's say before dry minus the weight of the can plus the weight of the sample after dry. And so now we have that for moisture loss in white Gari. Now this is white Gari, and so now the weight of the can plus the weight of the sample before dry was equal to what? 27.235 gram. And so for and then we say minus the weight after dry, and so this is the weight after dry, and so it is what? 26.974 what? Gram. And so now this is now equal to what? That is now equal to what? Now we have 27.3235 minus 26.974, and that will give us what? 0.261 gram. So now this is the amount of moisture that was lost in this food what? Sample. And so this is the moisture content in this food what? Sample. As simple as that. And so now, what is the next thing we are going to do? Now this is what they say is what? 0.21 say in grams to 0.21 And so now the next thing the question requires is what? Percentage moisture loss. Now to get the percentage moisture loss, you say percentage moisture loss. Now this is equal to, percentage moisture loss is moisture loss over the sample weight, that is weight of the sample times 100. So now you now have what? Moisture loss all over the sample weight times what? 100. And so now in this case, we have that the moisture loss was what? 0.216 gram divided by what? What is the weight? The sample weight. Now we had that the sample weight was what? 2 gram times what? 100. And this is equal to what? So we had that the sample weight is 0.261, sorry, 0.261, 0.261, sorry, 0.261 divided by 2. Now we had divided by 2 times 100. Now we had it to be 13.05%. And so the percentage moisture loss for white Gari is what? 13.05. And so this is the moisture content determination principle or method used to determine for what? Yes, yellow. Now we have yellow Gari, and so To get the moisture loss for it is the same approach. The weight before dry and the weight after dry, both the sample and the can. So we have that moisture loss is equal to the weight, let's say, before dry. This is for both the sample and the can. Before dry minus the weight after dry. So now we had for yellow Gari that the weight before dry is what? 26.592 minus the weight after dry was what? 26.359. And so this is now equal to what? We have 26.592 minus 26.359, and that should give us what? 0.233 gram. And so now the next thing we are going to do is to calculate for the percentage moisture loss. And so the percentage moisture loss is equal to the moisture loss all over the weight of the sample times 100. And so that is equal to, now we had what? The moisture loss to be 0.233 divided by 2. This is gram and this is gram times what? 100. And so we had divided 0.233 divided by 2 times 100, and so that will give us what is equal to 11.65 gram. And so the moisture loss was 0.233, and then the percentage moisture loss, that is percent, is what? 11.65. That is 11.65 what? Percent. And as simple as that, using the oven dry what? Method, we have been able to calculate for. We observe that white Gari's moisture content is higher than yellow Gari's moisture content during the processing. Moisture content after the processing. And so from the analysis we carried out, you see that white Gari had 13.05% of moisture, and then yellow Gari had 11.65. So going by this in a practical, or going by this assay, we can say that yellow Gari has a higher shelf life compared to white Gari. Thank you for being with us in this video. You can consider subscribing to our YouTube channel for us to bring more and more interesting videos with well explained and simplified calculation for you. And in our next practical, or in our next video, we'll be bringing forth ash content determination in a food sample, where we'll define and explain everything just as we've done here for you. Consider subscribing in our YouTube channel. To subscribe, press the red button for the subscription, and then press the bell for the notification, so that we'll notify you when our next video is ready. With these videos, you can use for your tests in your school. You can also use for your exams in your school for students who are in food science, who are taking the course, who are taking it as a course in the higher institution. Thank you for being with us in this video. See you in our next video. Thank you.